In this video, we'll talk about linear intercepts and intersections. And to quickly talk about the difference, an intersection is where two functions typically meet. So if you're looking at a graph, an intersection could be where two curves meet. So that would be an intersection point. Or where two roads meet, if you think about it that way. An intercept is where, by definition, where the function intersects one of the two axes. So for example, we know that that's a vertical intercept, and this is what we call a horizontal intercept. Okay, so for intercepts, what characterizes a vertical versus a horizontal? Well, a vertical is on the vertical axis. So a point here, what would that look like? Let me draw some tick marks. Well, that point would be 0, 2. If I draw another point, let's say right there, that would be 0, negative 3. So the commonality among all vertical intercepts is that they have the form 0, comma, something. And that something varies from function to function. Alright, well, what's true about horizontal intercepts? So let me draw a couple. What about this guy here? Well, that guy's located at 3, 0. Another one, maybe over on the negative side, that's also a horizontal intercept, because that's on the horizontal axis. That would have a coordinate of negative 2, 0. So what's common among all horizontal intercepts? Well, it appears that they all have an output value of 0. That is, they don't go up or down, but where they are horizontally can vary from function to function. Briefly, to talk about or remind us the difference between the words solve and evaluate. Evaluate is something that we say whenever we're putting something in for the input and trying to determine the output. That usually just requires us to manipulate a function of some sort. So let's say s of a, I don't know what s and a represent, but let's just say that s of a is 2a plus 3. Well, to find s as a function of an input of 2, we would just put in 2 for the input, do 2 times 2 plus 3, and we would get 7. So that's evaluating. We didn't have to solve anything or move anything around. But if we do, the output is 2 as a function of what input? Well, in that case, we actually have to solve the equation 2 equals what value of a, 2 times what value of a plus 3. This is where we get to move the constants over first. Negative 1 equals 2a. And then divide by the coefficient. And we would get a is equal to negative 1/2 or negative 0.5. So that's actually an instance where we would be solving. And that required a lot more work, of course. Let's take a look at a problem and start to reasoning through some of this stuff. A new company enters the market to sell electronic tablets, like an iPad. The company starts by manufacturing 1.2 million iPads. Production grows, I guess I shouldn't use the word iPad, tablets. Production grows by 0.08 million units per year. To attempt to keep up with demand, production can't seem to keep up with demand. Write a function that outputs the number of units produced. And maybe we'll call that P for produced, as a function of the number of years that have passed and since the company entered the market. And I'll call that T. So we want to look at what happens to production as a function of time. We know that we start producing 1.2 million, let's pretend that's there, in year 0. And every year it increases by 0.08. So 1 year later increases by 0.08. 1 year later increases by 0.08. And so we get a linear function that looks like that. So we know that initially production is 1.2, and it increases by 0.08 times the number of years that have passed, so 0.08 t. So we don't need to have the multiplication sign there, but we can just say 0.08 times t. Okay, so we've got our function. Let's ask another question. When will the company be producing 2 million iPads? And in this case, it says solve. Okay, so we know that the production as a function of the number of years that have passed is given to us by 1.2 plus 0.08 times the time. Now, what do we know? Is 2 million iPads, what's the question asking us to do? It's asking us to find the time. And we know that we're producing 2 million iPads. So that goes on this side. The number of iPads, or whatever these things are, is 2 million. And I want to know what value of t will coincide with 2 million iPads or whatever these things are being